Here's a question that sounds like it has an obvious answer. How old are you? Simple. You know the number. You've known it your whole life. Now imagine a database that stores your age. A column called age, the number sitting in it, seems completely unambiguous. It isn't. That single column, age, is one of the most misunderstood pieces of data in any system, and the problems it creates are responsible for wrong medical doses, incorrect insurance premiums, and customer records that silently contradict each other across the same company. Here's why. Imagine you walk into 4 different buildings on the same day. First, a hospital. The nurse asks your age. You say 32. She writes 32 in the system. That number means years since birth, rounded down as of today. Next, you walk into an insurance office. The agent asks your age. You say 32. He writes 32 in a different system. That number means years since birth, rounded to the nearest birthday. 6 months from now, their system considers you 33. Yours doesn't. Same number today, different number tomorrow. Nobody told the database which rule to use. Then you visit a paediatrician for your infant daughter. The doctor asks her age. You say 8 months. The system stores 0 because she hasn't turned 1 yet, but another system at the same hospital stores 0.67, 8 months expressed as a fraction of a year. One system thinks she's a newborn, the other thinks she's most of the way through her first year. Both say age. Both store a number. They mean completely different things. Finally, you walk into a wine shop. The label on a bottle says, age 12. That doesn't mean 12 years since the grape was born. It means 12 years since the liquid was sealed in a barrel. A different starting point, a different definition, the same word. This is the problem with age in databases. It looks like a fact. It behaves like an opinion. Because age is never just a number. Age is always a number plus a unit, plus a reference point, plus a calculation method. And most databases store only the number. The rest is assumed, silently, by whoever wrote the query. And assumptions, as we've seen before, are where data quietly breaks. Let's make this concrete. A hospital stores a patient's age as an integer at the time of admission. 6 months later, a doctor pulls that record and sees 45. Is the patient 45 now? Or were they 45 when they arrived? If it's the latter, the patient is actually 46. And if that matters for a dosage calculation, the error isn't theoretical. A retail company has 2 databases, one for online orders, one for in-store purchases. Both have an age column in their customer table. The online system calculated age when the account was created and stored the number. The in-store system calculates age fresh from the date of birth every time you run a query. When the company merges both datasets for a marketing report, the 34-year-olds in one system are 38-year-olds in the other. The data analyst sees a discrepancy, spends 3 days investigating, eventually finds that age meant 2 different things in 2 different systems. The column name was identical, the meaning was not. An insurance company stores age as age at nearest birthday, an actuarial convention. A developer joins the company, queries the age column, and writes logic, assuming it means age last birthday, the common everyday definition. For customers within 6 months of their birthday, the number is off by 1. Premiums are calculated incorrectly. Not for everyone, not obviously, just for the customers closest to their next birthday. The bug lives in production for 11 months before anyone notices. Same word, same column, different meaning, real consequences. So what's actually going on here? The problem has a name in data science. It's called semantic ambiguity. The structure of the data, a column called age containing a number, is perfectly correct. The meaning of that data is undefined, and undefined meaning, left to accumulate across systems and teams and years, is how clean-looking data becomes quietly wrong data. Age is just the most obvious example. The same problem lives in columns called price. Is that before or after tax? In columns called status, active as of when. In columns called date, the date something happened or the date it was recorded. in columns called name, legal name, display name, or the name on the account. Every column that looks like a simple fact is carrying hidden assumptions about what it actually means. So how do you fix it? The first step is documentation that lives with the data, not in a wiki nobody reads. The column should have a description, age in whole years at time of admission, not updated thereafter, not a comment in someone's notebook, a constraint in the schema itself, visible to every developer who touches that table. The second step is to store the raw fact, not the derived one. Instead of storing age, store date of birth. Age can always be calculated from date of birth. Date of birth can never be recovered from age alone. The raw fact is permanent. The derived number is a snapshot that starts going wrong the moment time moves forward. The third step is to align definitions explicitly when merging data from different systems. Before you combine two datasets, ask, does age mean the same thing in both? Not assume. Ask, check, document what you found. Because the dangerous thing about semantic ambiguity is that it survives data migrations, system upgrades, and team changes completely intact. Nobody deletes a misunderstanding. It just keeps getting inherited. Data can be structurally perfect, correct types, no nulls, no duplicates, and still be completely wrong because nobody agreed on what the columns mean. A number without a definition isn't data. It's a starting point for an argument, and in a database, that argument usually happens silently, in the gap between what one person stored and what someone else assumed they were reading.